Hello everyone, I'm Sri Lakshmi and today I'm here to discuss or teach you about two-way ANOVA. To the best of my knowledge, I'll try to explain what two-way ANOVA is, what are its assumptions, and how to do an analysis of two-way ANOVA using SPSS. Also, by the end of the presentation, I would explain how you'll have to report the results of a two-way ANOVA whenever you're presenting it, maybe in a publication for a publication or etc. So let's get started. Before actually going into what a two-way ANOVA is, I would like to talk about factorial design. So, what is a factorial design? A factorial design is an experiment or study with two or more independent variables. So, whenever you have, let's say, uh, gender and socioeconomic status, the effect of gender and socioeconomic status on diabetes levels, let's say. So, here, gender and socioeconomic status, they are two different independent variables. So, whenever there is a condition like that, you would go for a factorial design. So there are types of factorial designs: independent, repeated measures, and mixed design factorial designs. So independent factorial designs, usually they have a lot of, at least two or more independent variables, but they're taken from unrelated groups. Let's say maybe an experimental and control group. And then repeated measures factorial design, they are also having a number of independent variables, but from related groups, maybe pre and post test results. And mixed design, a sum of the independent variables can be from related groups, while some can be from unrelated groups. So usually factorial designs are also called as like factorial ANOVA, or let's say factorial ANOVA and factorial designs are used interchangeably. And two-way ANOVA is a kind of factorial design. So basically, two-way ANOVA is a parametric test that compares several means when there are two independent variables. So it needs, it needs that there are two independent variables which are generally categorical. And then it, like whatever it says, by the end result, it will show you whether there is an actual significant difference between the two groups, two groups or not. Otherwise, whether there is a effect of manipulation as seen. So this is very much similar to a one-way ANOVA. Uh, Basically, we are going to check about the variability between two groups, let's say. And usually, variability, there is systematic variance and unsystematic variance, or variance explained by the experiment and unexplained variability. So here, this experiment here, let's say it's just like two different groups. So whether there is a difference between two groups, which is caused because of that particular variable. So if at all that particular variable is causing, or we believe that it is causing the difference between these two groups, then we call it systematic variance. And this systematic variance, when, as I said, two-way ANOVA will have two independent variables. So there is a possibility that there is a main effect or the effect of the first variable, and then also the effect of the second variable. And we also check for the interaction between these two variables. So this is how the systematic variance is explained in two-way ANOVA, and even our results will get it in terms of the main effect of each individual independent variable, and then the interaction effect of those two variables, independent variables. So basically, coming to the assumptions of the test, it's a parametric test. So as we all know, data should be normally distributed, like within the groups, it should be normally distributed, and then homogeneity of variance should be met. So before the uh, before the experiment or the baseline data, both the groups should have like equal variance, equal or similar variance, and then the observations should be independent, because we're talking about independent ANOVA. I mean, two independent groups, unrelated groups, and two categorical independent variables with any number of levels. So gender is a categorical independent variable with, let's say, two levels, male and female. And then there could be another independent variable such as socioeconomic status, as I said before. And this can have high, low, average. So any different number of levels can be there, but the basic requirement is two independent variables. And then the dependent variable should be measured on a ratio or an interval scale. So it should be continuous. These are all the assumptions, and you'll have to check uh, whether your data is meeting each one of those before you actually go for a two-way ANOVA. So here let's take an example. Let's say we are trying to find out the effect of gender and type of death on complicated grief. So gender here, male and female, the levels are male and female. It's one of the independent variables. And then the second independent variable is type of death. And it could be because of accidents, homicides, or suicide. So these are my independent variables, and my dependent variable is the complicated grief. At this point, I would like to demonstrate how we would do this thing in SPSS as well. Okay. Okay, before that, I'll just tell you how the F ratio or the F statistics, which comes as the final output, even in SPSS, or if you manually calculate it also, you'd get an F ratio. So how do you interpret that F ratio? So F ratio you will get for the first independent variable, second independent variable, and also the interaction effect between the first and the second. So you'll have to report all three of these, and then you'll have to compare the obtained value of these F obtained for all these three categories to the critical values. So whenever the observed F ratio is greater than critical F ratio, we would reject the null hypothesis and say that there is a significant effect of the manipulation, or that there is a significant difference between the two groups. So it's like as I demonstrate and finally come to the interpreting or reporting the results, I'll explain it a little bit further. So here, critical values when you're taking, you'll have to check based on the corresponding degrees of freedom. And these are the formulas you can use for finding out the degrees of freedom for each individual IVs. It is n minus 1. And for the degrees of freedom for the interaction effect, it is the degrees of freedom for the first variable into degrees of freedom of the second variable. Okay. So now let's go to SPSS, and I'd run you from the very beginning of it. So, so here I've coded my data because I just gave 0 to be the male population and 1 to be the female. 0 here is accidents, 1 is homicide, and then 2 is suicide. So I'll just show you my variable view. So this is the gender as I've just told. These are the labels that I'd given, and these are the labels that I'd given for type of death. And just make sure that before you start your analysis, these measures are in the right scales, because your two independent variables are supposed to be categorical or nominal, and the dependent variable is a continuous or a scale variable. So once even that is checked, we can go for the analysis. But since this two-way ANOVA is a parametric test, it's needed. It's necessary that you check for normality. So I'll just show you one way to do that. So here you give the variables, just give the variables and plots. You need normality plots with tests. The others you can, I mean, it is necessary for other stuffs, but here, as we're just trying to understand what normality is, this would be sufficient for us. So continue and okay. So this will give you the descriptive statistics of your variables as well as the test of normality. So this it's Kolmogorov-Smirnov test, and as you know, when p is greater than 0.05, that would mean that the data is normally distributed. So this is for complicated grief and then gender. So like that, you'll have for both the variables normality test. So once you are sure that your data is normally distributed, you can go for the next analysis, next part of the analysis. So here I'm not showing you a separate test for homogeneity of variance, because as we are giving the commands, or um, as we are following the steps for two-way and ANOVA analysis, there itself will get Levin's test, which is the test for homogeneity of variance. So to analyze or to do analysis of two-way ANOVA, we'll go for general linear model. So univariate, and here you just put these variables, your dependent variable in the dependent variable column, and the gender and type of death to be the fixed factors. Now, just this plot will show you the interaction effect. Like, it gives you a visual representation of the results that you'll get out of the two-way ANOVA. So I'm just giving them add, continue, and then options. You can opt for descriptive statistics again, and homogeneity test. Here, the Levin's test will come as you're done. For the post hocs, let's come to that once we're sure that there is a significant effect, or there is some significance for our variables. So as of now, with this much done, I'll just click OK, and we'll get our results. So first, it starts with the descriptive statistics. Here you see the values, mean values, and standard deviations are given. And then Levin's test. Here, Levin's test also, the interpretation is when the p value is greater than 0.05, then homogeneity of variance is present. So, our data shows that there is homogeneity of variance, and here we go. So, as you can see here, for gender, separate f value and everything is given, and even for type of death, we have data, or we have the final result, and the interaction effect is also calculated. And by looking at the significance level, or the p value, you can understand that only type of death was less than 0.05. So that means only type of death had a significant effect on the dependent variable, which is complicated grief. The others, the other two, gender, no, and the interaction effect is also not there. So since type of death had like three levels, let's just like do the post hoc test too. So again, going back, it'll just give you everything again. But still, you can just select. Since gender has only two levels, you don't really have to go for a post hoc test. But type of death, since it has three levels, we'll go for a post hoc test. So there you go. You can choose the tests that are going to be relevant or appropriate for the data that you have. Here I'm just choosing these two tests, and when you run it, you'll get all of these, but you just have to go back to the uh, this is the post hoc table, and as you can see here, there is a significant difference. See, 0.03 and 0.01. So there is a significant difference between accident, I mean, in the complicated grief levels, between because of accident and suicide, and also homicide and suicide. Yes. And you can, here, by looking at the interaction plot also, you can see that in both of these, um, this is the blue line is males and green line is females. So for accidents and homicide, there wasn't any big difference between the level of complicated grief. But when it came to suicide, the complicated grief levels have shot up. So that's exactly what the data is telling you, that when suicide is the cause of death, the levels of complicated grief could be higher than compared to accidents and homicide. So since we have all the data right now, I'll just like finish it off explaining you the interaction plots, and then the final how to report or present your data, present your results when you are writing a paper, let's say. So here interaction graphs, if you can, I mean here as it is mentioned, when lines are all parallel, it indicates that there is no interaction. So here if you can see, this is an example I had taken from Andy Field's statistics book. So here these two lines are parallel. So that indicates that there is no interaction effect between these two variables, which is like alcohol consumption and mean attractiveness of date. But when there is a, when there is a interaction or the lines are cutting through each other, then there could be a possibility of interaction. So just based on the interaction plot, we cannot really say that there will definitely be an interaction, but usually whenever there is a cutting through or when the lines are non-parallel, there is a possibility that the interaction could be there and it could be significant. So whether it is significant or not, you'll have to find out through the analysis results. Okay, so in our example, as you know, these are parallel lines. So it basically isn't showing that there will be any interaction effect, and that is substantiated by our analysis results as well. So there was no significant interaction effect. And now, coming to the reporting part, you'll have to report the details of the F ratio and degrees of freedom for which it was calculated for both the main effect and interaction effect. So here, uh, type of death was one of our independent variables, and we've seen that there is a significant effect of it on complicated grief. So you just have to report the F value, which is, I'll just show you. Okay. So F value, type of death, 5.012. And degrees of freedom, you will have to calculate it using the formulas that I've mentioned before. So once that is done, you'll just have to report it. And then you can also talk about the post hoc difference as well. Post hocs. So here you will just write the values that are there. So over here, your okay. So it is not actually both less than 0.001. It is less than 0.05. So that indicated that there is a significant difference between those two groups. And then level of complicated grief in death due to homicide and accident were not significantly different. As you can see over here and over here, the values aren't significant. So then you have to report the same or like report the F value for even the second independent variable, which is gender, and then F value plus the P value. Since there was no significant effect, that's all you can write about this. And then even for the interaction effect, there is no significant interaction effect between type of death and gender of the person on complicated grief. You again have to report the F values, P value with the degrees of freedom, and then uh, yeah, you just have to yeah. Okay, this line is not needed. You just have to report this much. So with this, two-way ANOVA has come to an end, and it's a pretty straightforward analysis, if you could ask me. It isn't very difficult to understand, but it does have some technicalities to it. So just read about it and explore more. So yeah, thank you.